Okay, let's continue with our review for the Unit 4 exam. And now we want to talk about Lesson 21, which was on electric current. And you'll notice that I took the energy from down here and I put it up here. And so that's the reason for doing that, is so that we can put current and resistance. And so those circuit things are all going to be organized together. So you didn't have to do that if you didn't want to. And then also remember, you need to know what a joule is, and you needed to know what the volt was. Okay, so this in your textbook, this is going to be chapter 23. And you do not need to know anything from the column there on the pink, so don't worry about that formula. But you should know what the formula for electric current is. So let's put that here. The definition of electric current is it's going to be the amount of charge Q per unit time. Now you don't have to put the triangles on there. It's just good form to do that, but I'll just leave it like this. It's the amount of charge Q that is flowing in a wire per unit time. So remember that electric current is going to be the flow of electricity. And then the official metric unit for electric current is going to be the amp, or the ampere. So you should know that. Okay, you should know that 1 amp of current can kill you. Okay, so that normally in electronic circuits it uses very, very small amounts of current, milliamps of current. But 1 amp of current is very dangerous. Okay, then the reason why electricity flows in a wire. Okay, so there's 4 reasons why electricity flows in a wire. 1, it's experiencing a force. So the force is pushing the electricity in the wire. Another reason is it's in a field, an electric field. So this pen is in a gravitational field, so that's the reason why it falls. In a wire, the wire sets up an electric field, and then the electrons are following that electric field. Another reason is electrical energy. So energy, E, that one end of the wire is at higher energy than the other end. And then the electricity will flow downhill towards the lower energies. But the one that I want you to know is voltage. So electricity flows because of voltage. So it's the pusher of the electricity. So the current is going to be the flow of the electricity, and the voltage is what's causing the current in the first place. It's the thing that's doing the pushing. Now this is very, very important. It's changes in voltage that causes electricity to flow. So that, let's say, for example, that you have a wire, and then there's a resistor, and then there's a wire, and then over here we have a battery. Okay, can you tell me what's going to happen if I connect this wire over here? So if I connect that wire, the electrons are going to come out of this thing here. They're being pushed by voltage. It's a chemical thing. So the chemicals inside the battery are giving energy to the electrons, and then they're coming out, and then they go through the resistor, and then they go back to the battery. But what do you think would happen if on this side over here we have another battery? And notice the way that I just put it in there. So this battery over here its negatives are coming out the top, and these negatives are coming out the top. So how much electric current would be in the wire? 0, because it would be changes in voltage. So that normally you're going to have the battery by itself, and then the electricity is going to go around to back over to here where it's 0. So it has 0 voltage by the time that it gets back to the battery, and then it's got some initial voltage when it comes out. So it's changes in voltage that cause the electric current to go. So can you explain why is the bird okay as long as it's got 2 claws on the wire? So even that wire could be at 100,000 volts, but that bird would be okay. Okay, don't worry about this yet. Okay, so we're only concerned about voltages at this point. Okay, then we've got resistance. So resistance R, and then the official metric unit is going to be called the ohm. So that's one of these things. So that stands for, it's the official metric unit of resistance. Resistance is going to slow down the flow of the electricity. And so we've got this formula here for resistance. So we're going to say that electrical resistance is going to be equal to some constant that depends on the material. So some materials are better resistors than others. So this is called the resistivity. Wood would have a large constant, but copper would have a very small constant. So copper does not resist the flow of electricity. And then it's going to depend on the length of the wire, and then it's going to depend on the area of the wire. So I could ask you on the exam, what would happen if I increase the thickness of a wire? So the wire was initially this thick, and now it's this thick. So what would happen to the resistance of that wire? Well, we're making the A big, so that means the R gets small. So it would decrease the resistance. So that's the kind of question I would ask you. Okay. All right, let's take a break, and when we come back, we want to connect V, I, and R.